In this video, I will explain you how to take sign while you are taking the measurement of image distance, object distance, then focal length, then radius of the sphere. So I am going to consider a concave mirror. So for the concave mirror, we will have inner surface as the reflecting surface. Now we know that to form an image, we need two rays. So I am going to consider a ray. So this is, let's say, the center, and my object is far away from center, and it would form an image. Yeah, so we will see different rays first. One thing is, any ray which is parallel to principal axis, after reflection, that would go through a point that is called as the focal point. First thing, any ray which is parallel to the principal axis. Principal axis is the line passing through center of the curvature. This is the center of the curvature. Okay, center of the curvature and pole is the principal axis. The line passing through C and P is the principal axis. Now any ray parallel to this would go after reflection through a point which is called as focus. Now any ray which is going through C, through center of the curvature, any ray which is passing through the center of the curvature, after reflection that would go in the same direction. Because see here, this would be the normal. Now with respect to normal, incident ray makes 0 angle. So after reflection, that should also make the angle 0. So with a line, the angle made, if it is 0, that would be in this way. After reflection also, that would be 0 angle made. Okay, so this would be the case. Second case, passing through C. Now next case is any ray which is directly going towards pole, after reflection that would go in a direction which is maintaining the same angle that the incident ray is made with principal axis. I will repeat it. This is the incident ray, right? The incident ray will make an angle theta. Okay, let's say this is angle theta with respect to principal axis. See, one thing is very sure here. The principal axis at this point would be simply the normal at that point. See, this would become normal. This line would become normal at this point. So then just apply the laws of reflection. With respect to normal, incident ray is making an angle that should be same as that of the angle made by reflected ray with respect to the normal. Or I can say, with respect to principal axis, the angle made by incident ray should be equal to the angle made by reflected ray with respect to principal axis. This is the principal axis. So in both ways it is the same, but when it is directly hitting the pole in this way, after reflection that would go in this way, making sure that the angle made with respect to principal axis by incident ray is equal to the angle made by reflected ray with respect to principal axis. The first case was just going parallel, so the incident ray parallel to the principal axis would send the reflected ray through a point called as focus. It is the focus, and this is meeting P. And the second case I have explained is, that is passing through C. After passing through C, the reflected ray would go in the same direction. That would retrace the path, going in this way, returning back, going in this way, returning in this way, going in this way, and passing through focus. And any ray which is going through P, that is through principal axis, ray can also go in this direction, right? So it is the same case which is passing through C. See, this light ray is passing through C, this light ray is passing through C, even the principal axis is passing through C. So any incident ray going in this direction, that after reflection that will go in this direction. Okay, so these are the light rays, and you can see here the image would be formed. Okay, here the image would be this thing. Okay, now we have this as the object distance. Object distance would always be measured from P. Always the distance is measured from pole. Okay, from pole where the object is, we will draw a line, straight line till there, and this represent my image distance, sorry, object distance from pole to object. So what is object distance? Distance, that is the distance in between, distance between pole and object. So pole and object, from pole to object, this is the object distance. Next is image distance. Image distance, distance between pole and image. Where is the image? Here is the image. So always pole, from pole we have to take the measurement. So image, object from pole to image. Now image distance from pole to image. Object distance from pole to object. Image distance from pole to image. Between pole and object, between pole and image. Okay, that is represented as V. Here it is U. So here it is V. Now what is focal length? Focal length, that is distance between pole and focal point F, and that is represented as F. Next thing is radius, that is distance in between, distance between pole and center of curvature, that is marked as R. Okay, now all these points are only giving magnitude, right? What would be the direction? Distance in between pole and object measured from pole. This is very important, measured from pole. Here also measured from pole. Here also measured from pole. Here also measured from pole. Now read it. See, object distance is the distance between pole and object, that can be measured from pole and also can be measured from object, but we are measuring it from pole. In all the cases we are taking the measurement from pole. That is very important. Okay, now we are going to take the positive direction as the direction of the incident ray. Now incident ray in this case is having the direction this. From the source, incident ray is coming in this direction. So this is going to be taken as positive. Any direction opposite to this is negative, and also upward is taken as positive and downward is taken as negative. Leftward is taken as negative. So in a very short, I could say that just draw an XY axis. X, Y axis. This is X axis and this is Y axis. This one is positive and this one is also positive, but this one is negative and downward is negative. See, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. and this is minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. This is 1, 2, 3, 4. 1, 2, 3, 4. This is minus 1, minus 2, minus 3. See, positive, rightward is positive, leftward is negative, upward is positive, downward is negative. Okay. Okay. Now, this point can be considered as pole. So from pole, rightward is positive, leftward is negative, and upward is positive, and downward is negative. So this is how you have to take the measurement. Now from case to case, in numericals, we will see how actually it can be substituted in an equation. Okay, thank you.